This question works with a sphere and a square-based pyramid which share a similar dimension, in this case the measurement of x. It appears in both, and it's a problem where you take the information from one object and you apply it to the second one. So looking at the question, we have our sphere here which has a diameter of x, and we're given the total volume for the sphere in terms of pi, 288 pi centimeters cubed. We have a square-based pyramid here, which is, I think, labeled correctly, and you are asked to find the total surface area of the pyramid. So with a question like this, there's two shapes. The final part is to do with this object here, so we begin with the one on the left. And we look at this and go, well, what do we know? We know the volume, and so therefore, if we know the volume, we can clearly work out what the value of the diameter is, and if we can do that, we know what x is, and then we can apply x to our pyramid and hopefully work out the total surface area. On the exam paper, you are given the formula to use for a sphere. So the volume will be equal to 4/3 pi radius cubed. Our volume in this case is 288 pi. So we substitute that in to get this. Now, don't worry about the pi because we can just cancel. We can divide both sides by pi. So the pi will disappear. And we then will have 288 equal to 4/3 r squared. Multiply both sides by 3, 288 times 3, divide both sides by 4, and we get the value of r, I should say cubed, sorry, should say cubed. So r cubed, getting all confused, r is the cube root of 288 times by 3, divided by 4. And then when you put that into your calculator, r will come out to be the cube root of 216, which maybe you know is 6. So 6 centimeters. And if r is equal to 6, that's the radius, then x, which is our diameter, is equal to 12 centimeters. And we'll use that now with the pyramid. So focusing just on the pyramid now, we know that x is equal to 12. So we can change all our dimensions now on our diagram. So we have 12 centimeters here, we have 24 centimeters here, and we have 60 centimeters as our height. We want the total surface area. So that's the 4 triangular faces plus the rectangular base. Let's do the base first because that's the easiest thing. So we want the area of our base, and that is simply 12 multiplied by 24, which equals 288 centimeters squared. Now looking at the pyramid, we have 2 different types of triangular face. We have ABC, which is the same as ADE, and then we have a different one here, which is ACD, and that's the same as AEB. So we have to work out both and then use 2 of each. So let's work out the first one of those. So let's work out the area of triangle ABC. So ABC looks a little bit like this, where we have B and C at the bottom here, A at the top, and we know the base here is 12 centimeters. But we will need to know the perpendicular height of the face to work out the area of that. Now that measurement there, I'm going to mark it in green, is there on the face of my triangle. So to work that out, what I need to do is create another triangle here, using the height and down to the center and out to the side. So let's draw that one in green on here, just so you can visualize it. We've got O, we've got A. We know the height is 60, and we know the base of that triangle is 12. It's got to be 12 because this length here is half the length of here. So I can use Pythagoras now to work out this missing distance here and then use it here. So what I've got here, this measurement here is going to be the square root of 60 squared plus 12 squared, which is the root of 3,744. Now I can write down the area of my triangle ABC. It's a half multiplied by the base, which is, this case is 12, multiplied by the height, which is root of 3744, which is equal to 72 root 26. Now let's look at the next triangle. So I'm going to look at the area of triangle ACD. So that's this one on the right-hand side of my pyramid here. The base is 24. I don't know the perpendicular height again, so I need to work that out. Let's just label this so I'm clear on where I'm going. Let's do this one in blue this time. So I need the perpendicular height, so the diagonal length there. So I need to create a right angled triangle here, again from the center. Do that one in blue. And I know the base of this triangle will be 6 because it's going to be half of the length BC. And the height is still going to be 60 because this is the height of my pyramid. So the long side, the hypotenuse here, is going to be the root of 60 squared plus 6 squared, which equals the root of 3636. Now I can work out the area of my triangle. So the area of my triangle is equal to a half multiplied by the base, which is 24, multiplied by the perpendicular height, which is my root 3636, which simplifies to 72 root 101. So now I've worked out the areas of my three shapes. I just need to add up the correct amount of each of them. So my total surface area will be the area of the base, which is 288, plus 2 lots of side ABC. So it's 2 times 72 root 26, plus 2 lots of ACD, 2 times 72 root 101. And then if I put that into a calculator, I will get the result of 2,469.440899. Let's check with the question. It says to the nearest centimetre. So that's going to be 2,469 centimetres cubed, because the 4 will tell us that we round down. And that's the complete answer.